We are now going to talk about how we use base E exponential formulas and functions and their applications. And one of the few E formulas that we'd like you to learn and to use is the compounded continuously equation. This is similar to compounded interest problems, but every second it's being compounded. So this is going to be the amount in the account is equal to P, the principal, times e to the RT power. Now notice both the R and the T are up in the exponent. So we have our principal, we have our interest rate, and we have how long we let it sit. And if we use all of those correctly, that'll give us the amount after T years. So time is measured in years, but it's compounding every second. So to use this formula, we're going to show the following example. If a quantity P increases or decreases at an annual rate R, compounded continuously, the amount A after T years is that formula we just gave you. So, to use it, suppose that we invest $25,000 at a rate of 8%. This sits for 50 years, and so we want to know how much we have. So our A after 50 years is equal to our amount times E raised to the 0.08 times 50. So there's our time, our interest rate, and our principal from the problem. To go any farther, we want our calculator. So we get 25,000 times parenthesis 0.08 times 50 close parenthesis e of x. So notice that the power of e now applies, and I had to do it because of the way this calculator works, that x says it needs to be on there before I hit it. But when I hit enter, it's going to tell me how much money's in there. $1,364,953.75. And no, there's no typo here. If you can let something sit that compounds continuously at 8% interest for 50 years, you can start with 25,000 and end with almost $1.5 million. And that's using the formula. Notice again, though, that I used the calculator to evaluate that so that I could get the proper answer.